All right, CNT140, we're looking at the premise cabling chapter 2, chapter on cabling jargon. I think the book says in the beginning you can almost treat this as like a glossary for the whole book, if you will. And yeah, there's a lot of things in here we'll hopefully remember from 120, but there's going to be plenty of things in here we're like, okay, we haven't heard of that before, but we can use this chapter 1 as a place to look them up or at least get a handle on what they're talking about. So we're going to learn a lot of terminology, a lot of jargon to kind of understand what we're talking about in this field. The key to understanding a technology is understand the language of that field, in this case of this technology. What is premise cabling? We touched on this in chapter 1, the cabling inside of a building and at a business, at a school building, at a college building, those kind of things, that kind of cabling in that facility. Your structured cabling is defined by your TIA 568 standard or internationally ISO 11801. Okay, and I even remind you that here about which one. And this is used for LANs, networks, telephone systems, security systems, even other environmental lighting, heating, ventilation, lighting, those kind of systems. Signals are sent across these networks for management purposes. This was the picture used in chapter 1 showing the structure. And then these are the pictures I used to show you the same kind of structure, maybe broken out into what might look like for a building for you. So I'm here reminding you that, you know, down here might be the main closet with servers and things in. These closets up here would be, you know, your secondary ones, your telecommunications rooms. Connecting the switches in these closets is your vertical or backbone cabling, the fiber optic cabling typically connecting your switches together. And then from the closet out to the outlets in the offices or the rooms would be your horizontal cabling, your copper cabling. And then you have patch cables going from there into your PCs. Okay. So that is typically your structure. I have it broken out here for you again. You can see the pieces. There's your patch cable in the work area up to maybe 5 meters of patch cable, outlet on the wall, horizontal cabling going up through the wall or on the channel on the wall, above the ceiling, down the hall, typically supported by cable trays, into a network closet, into a telecommunications room, into a patch panel, that interconnection point for all the cabling coming down the hallway. I can use that to connect that drop into this switch or a different switch in my closet for different purposes. And then again, another couple meters of patch cable allowed here for that connection. If I add all those up, 5 plus max 5 here, max 90 here, max 5 here, all that together gives me my maximum of 100 meters for my signaling. If I have a multi-floor building, that structure gets repeated, and then there's that fiber optic link going from the switch in this closet to the switch in this closet. That's your typical structure. The book says, hey, many people call it different things because of usually kind of the use, what they're used to using it for. I try to continue calling it your standard install or structured cabling because that's the kind of thing we're usually focusing on for our network usage. Yeah, and again, here they're reminding you premise cabling for the application or structured cabling after the 568 standard. They remind you again, things like IEEE 802.3 make standards for Ethernet and for communications. Wi-Fi 802.11, there's various forms of that for wireless communication. But these are standards for your electric signaling and moving of data. And they also remind us standards are not codes. Yeah, we'll touch on that again as well. Structured cabling is based on a number of industry standards from the manufacturers that want their products to work together. And as we said, those different organizations came together and said, hey, if we want to move data around, let's do it, you know, this way on this wire and this voltage and that sort of thing. So they're developed a cabling standard that voluntarily, it's not required, voluntarily use so that things should work together. There should be interoperability. Developed by EIA, TIA for the US, and ISO for worldwide standards. And then again, here's a reminder, 568 for your structured cabling, 569 for closets, pathways, spaces, 570 for residential cabling, 606 for documentation, labeling kind of thing. 607 for grounding and bonding. And then here's the international equivalents that we had mentioned back in Chapter 1. They're here for you again for easy reference. They also remind us that standards are voluntary. I don't have to do the standard install, but I also know that if I do, things should work together. Things should work together. Codes, however, National Electrical Code, that is required. I do need to follow that, or my electrical wire in the building might not pass inspection. I might have to tear it out and do it again. And that is for electrical safety and fire safety, if you will. 800 Article 800 covers the communication circuits. 770 covers fiber optics. And then here was that chart we showed you back in Chapter 1, showing you the different areas of the National Electrical Code, and roughly 770, 800 of the pieces that we would be paying attention to most. As we said, structured cabling defined by 568 here in the U.S. Internationally, ISO 11801. It's going to include using copper cabling and fiber optics. Copper cabling typically for the horizontal cabling, as we looked at here. I'm going to jump down here. Copper cabling typically for the horizontal cabling here, UTP. Also here for closet patch cable, and out in the work area patch cable. That's typically all going to be copper UTP. It also allows fiber optic. And as we said before, that's typically for, let me show you this picture again, connecting my closets together. These could be separated by a floor, or these could be literally in two entirely different wings of a building that I need a long fiber link to connect them. So the fiber optics typically used for bandwidth as well as distance needs. Standards are based on a maximum length of UTP cabling at 100 meters, so 90 meters for horizontal cabling and 10 meters for patch cords. And that's what we have on this example I've been using to show you. 90 meters max for horizontal, and then 10 meters for patch cable. So 5 here and 5 here, if you will. And all that adds up to be 100 meters or less. That's what the standard is calling for. 90 meters for that permanent link that's installed, that permanent link. Here's the example that the book was using. Here's an example I was using previously, showing the closets and the horizontal cabling workstations. This is the other example Mr. Brown was showing, showing all that, and if I have a multi-floor building as well. So hopefully all that is coming back to you from Chapter 1 as well. They do mention about your fiber to the home, your passive optical LAN, and showing you the whole, you would actually have a fiber connection out to a switch in an area, and then multiple devices, or in that case, multiple homes in an area connecting to a switch down the block, if you will. Okay, now we're going to get into some structured cabling terms. So this is where I'm going to have a lot of show and tell for you. I have a lot of pictures in here to help you see what they're talking about. If you're like me, when I see some examples, I'm like, I know what they're talking about. So telecommunication room, it's basically, it could be very small, but a room that I'm putting my patch panels and switches and types of things in. So these parts of my building. It might be a small rack with some patch panels and switches in to connect my horizontal cabling over to the main closet in the building. So it might look something like that. It might look something like that. It might even be as small as this right here. Literally the size of, a handful of books stacked on top of each other, if you will. All I'm really doing is interconnecting those two pieces here, the horizontal cabling here to the backbone cabling here. That's all I'm really doing with those telecommunications closets. The main cross connect, that's an old term for the main equipment room that you would have today. That would be this part of your building. The main, maybe the entrance facility, maybe where your main servers are, maybe if you still have phone equipment, where your phone equipment is for the building. It is going to look more like this. I'll have probably a couple more racks. I might even have, I think I have some other examples here. I might even have a couple rows of racks, depending on the facility. I might have some phone equipment. Now, some of this is kind of getting old school here, but I might have some phone equipment with some large chassis switches. I might even have rows of cabinets that I have servers in. Here's another one that's rows of servers in. So this would be my main equipment room for my facility. Old term is your main cross connect. Intermediate cross connect. would be a room that I would use between my, let me go back up here, room I would use between the main closet here and these telecommunications rooms here. Well, it's kind of a special case. The example I like to use is if I'm dealing with a large college campus, I might run a piece of backbone cabling across campus to an intermediate cross connect. This might be, this might be the main part of campus, and this might be the older part or maybe the newer part of campus that was added on. I run a fiber link over to there into a building there, and then I split it out to maybe the 2 or 3 neighboring buildings around it using shorter distance of fiber optic cable into those closets, into those buildings. So it's kind of a special case, but it is that branching out point, that intermediate cross connect. And I like to think of it as like, going across college campus with a fiber, then branching it out to 2 or 3 buildings that's near that. Work area or work area outlet. This is where your user is sitting with their desktop, their computer type of thing. It's these parts of my building. It's these parts of my building where I have my workstation and a patch cable plugging into an outlet on the wall. It's this part of my structure, that outlet box on the wall. It's this part of my structure, the outlet box on the wall, outlet box on the wall, outlet box on the wall. That is your work area and or your work area outlet. If I crack it open, which we're eventually going to do this, we're eventually going to terminate outlets of our own. This is the kind of thing I find behind the faceplate. That kind of outlet that I'm terminating into. The horizontal cabling is terminating into that outlet for the user to plug into. And there is a color code to follow and a certain sequence that I need to do my wiring in. Patch panel. Well, the other end of my horizontal cabling is where the patch panel is. Okay, so if I go back to, actually we'll go right here. Here is my outlet, my work area outlet. Horizontal cabling comes back into the closet into a patch panel. So the patch panel is this connection point, and this is a close-up view of the front of the patch panel. This is this connection point where all the cabling in the floor comes into this patch panel, and the patch panel allows me to plug that port into switch A or switch B, or disconnect that port. Maybe that port's in the hallway and we don't want people using it, so I disconnect it. And for safety reasons, it's a dead port, if you will. But I can patch it in if we need it for something. Okay, so all those connections come to a patch panel. They come in different sizes, 24, 48, 96. This kind of correlates to your switch sizes, 24-port switch, 48-port switch, etc. Okay. The front is that port that I can use to plug a patch cable into to patch it into a switch. The back is where I'm terminating the horizontal cabling to. This is where I'm punching the wires into. Again, here's my patch panel, horizontal cabling coming into the back of it. This is where I'm punching the horizontal cabling into the back of the patch panel. We will do that as well. After we do the outlet, we'll turn around and do the patch panel termination. And then here, the horizontal cabling is patched in the back. Now I can use a patch cable to connect from there up to a switch. Okay, that type of thing. That's what that's giving me. That's what that patch panel is giving me, that interconnection point. Patch cord is just that short cable that I'm going to use to connect computer to a wall outlet or patch panel to a switch kind of thing. Okay, so here I'm connecting computer to a wall outlet, or I might be connecting the patch panel to a switch port. Okay, computer to a wall outlet or my patch panel to a switch port. And my patch cables have this type of connector on the end, modular 8-pin connector. A lot of us call it RJ45. That's kind of a slang name, if you will. That's a modular 8-pin connector. And they do have pinouts, the 568A and 568B color code pinout for terminating that patch cable. That patch cable is typically stranded conductor, unshielded twisted pair cabling, stranded conductor for flexibility purposes. So this cable here is usually stranded core, so the cable can bend a whole bunch without breaking. It's typically that stranded cord for flexibility. All right, when we come back, we're going to continue on with some more terms. We'll move on to the horizontal cabling.